Okay, so today we're going over Module 9, called Properties of Parallelograms. And the objective is students will discover the properties that make a quadrilateral a parallelogram. So if you go into our first example here, it says, what is a parallelogram? So the definition of a parallelogram is it's a quadrilateral whose opposite sides are parallel and congruent, opposite angles are congruent, and diagonals bisect each other. So what this means is that where it says opposite sides are congruent, that means if you think of side AB and side DC, those are parallel and congruent. And the way we show they're parallel is they're going to have like a little indication, like a little arrow there. So that means those are parallel. So that means we're going to say that AB and DC are congruent and parallel to each other. And the two other opposite sides here are side AD and side BC are parallel and congruent to each other. So the way you mark that is instead of putting one arrow here, you put two arrows like that. Okay, so you also say that AD and BC are congruent. Okay, the next thing is the diagonals are the lines that go from one corner to the other, like that. And you just put the point E in the middle. And then when we say the diagonals bisect each other, that means that E is in the middle. So that means that A to E and then E to C are congruent to each other. So you're going to put a mark right there. So we're going to say that EE and EC are congruent. We do the same thing with the other two sides. We say that side or segment DE and EB are congruent to each other as well. So then we put this 2. We say DE and EB are congruent to each other. Okay. Now, the angles that are opposite each other, what that means is that so let's, for example, angle A and angle C are congruent, are the same value. And then you also say the same thing about angle D is across from angle B. So here we're going to put 2 marks to show us a different angle. So we'll say that angle D and angle B are congruent to each other. Okay, so using this, let's get to our next example, example 2, using properties of parallelograms. So we're going to solve for segment AD. And if you look here, so this is a parallelogram. That means that AD and BC are congruent to each other. So we state that first. So we say BC is congruent to AD. So what we do next is we substitute in the equations for each problem. So we saw that for BC, it's this equation. For AD, it's that equation. So we set up 5x plus 19 equals 7x. So what I do next is subtract 5x. Move this over here. So I get 2x equals 19. And then I divide by 2 on both sides. So I end up getting here x equals 9.5. So remember, this is not our value, our answer yet. We just need to plug it in. So we need to take this 9.5, and since we're solving for AD, I need to take it and plug it in right there. So what I'm going to do here is I'll say AD is 7x. So that means it's the same thing as 7 times 6.5, which is 45.5. So that would be my answer. Okay, now example 3. So we're still using the same figure, but this time I want you to solve for angle B. So what you notice here is angle B here and angle D are opposite each other, so that means they're congruent. So we're going to take this equation and this equation and set them equal to each other. So we're going to say angle B is congruent to angle D. So we substitute here. So I'm going to subtract 6y first from both sides. I'm going to get 5 equals 2y minus 6. So here, minus 17, I mean. So I subtract 6. This one goes away. And I'm going to add 17 to both sides, which is going to give me 22. So I just added 17 to both sides. Remember, this one eliminates. We add 17 over here. So 5 plus 17 gives us 22. Now I divide by 2 and I get 11. So what I'm going to do here is take 11 and I'm going to plug it in right there. So I'm going to say angle B is 6y plus 5. So we have 6 times 11 plus 5, or 66 plus 5, which gives me an answer of 71 degrees. Okay, now example 4. So I'm going to solve for a segment PR. So this segment here is this right here. And remember that diagonal is made up of two parts, P to T, and then T to R. So remember, those two parts are congruent to each other. So we're just going to say that this segment and that segment congruent. So we're going to say PT is congruent to TR. So all I do there is substitute in the values. So I get x plus 9 equals 4x minus 6. I subtract x first. So I subtract the x. And I subtract x over here. So these go away. I get 3. So then I add 6 to both sides. So I get 15. And I divide by 3. So I get x equals 5. So what I'm going to do here is take my x equals 5. And I'm going to plug it in this time to both x's because I need to solve for segment PR. Okay, so remember what it says here, segment PR is made up of two segments, PT and TR. So we're adding those together. So we have x plus 9 plus 4x minus 6. So I'm going to substitute in 5 for every x I see. So inside I'm going to get 5 plus 9 plus 4 times 5 minus 6. So what I'm getting here is 5 plus 9 is 14. Here I get 4 times 5 is 20 minus 6 is 14. So 14 plus 14 gives me the value of 28. So PR equals 28. Okay, next question. Example 5. So for example 5, we're going to verify if it's a parallelogram. So it says here, if x equals 7 and y equals 4 is the following a parallelogram. So what we have to show here is that this segment and this segment equals each other. So what I'm going to do here is I'm going to take x equals 7 and plug it in here. And then I'm also going to plug it in right there, just to see if they're the same. So if they're equal to each other, and we also have to show the same thing for the other two sides. So here, I have to show that BA and CD are also equal to each other. And the same thing, I'll take y equals 4. I'm going to plug this one in here, and I'm going to plug it in right there. So I'm going to show it first and to prove that BC is congruent to AD. So all I do here is just take x plus 14 equals 3x, and I'm going to plug in 7 into the x. So 7 plus 14 equals 3 times 7. So 21 equals 21. So we say BC equals AD. The first part, so that worked out. You check that off. Okay, next one, you have to show that BA and CD are equal to each other. So do the same thing there. 5y minus 4 equals 2y plus 8. And I'm going to plug in a 4 in for the y's. So 5 times 4 minus 4 equals 2 times 4 plus 8. So I end up getting 16 on one end, 16 on the other. So we say that BA is also equal to CD, congruent to CD. So because both of these worked out, I say it is a parallelogram. Okay, now example 6. Again, we're going to verify if it's a parallelogram. So here it's telling you if x equals 3 and y equals 8 is the following a parallelogram. So again, here they give you the diagonals. So what we have to show here is that this segment and this segment equals. And same thing with this segment. These two are congruent to each other. So I start off by showing does JN and NL, are they congruent to each other? So these are this is this segment and NL is this segment. So they have to be equal to each other, congruent. So I'm going to take 2x plus 2 equals 4x minus 10. And I'm going to take my x equals 3. And I'm just going to plug it in to both x's right there. Okay, so it's going to be 2 times 3 plus 2 equals 4 times 3 minus 10. What I end up getting here is 8 equals 2. But since they don't equal each other, this part does not work out. So we say since Jn does not equal NL, it is not a parallelogram. Okay, so example 7, you just have to just figure out are these parallelograms or not. So if you look at first shape here, you see the little arrow there? That means that they're parallel and congruent. So that means that this segment and that segment are parallel. And then this segment and this segment are parallel. So we say the first one, that's a parallelogram. Okay, let's look at the next shape. Here, this side and that side are parallel. But if you look at this side here, they're congruent, but these two are not, they're not parallel. So just write that down, not parallel. which is not parallel. So we say here that this is not a parallelogram. Okay, if we look at the next shape over here, you see that all the sides here are congruent to each other. So when they're congruent to each other, okay, these are parallel, and same thing with these. And if you look at the angles, opposite angles are also congruent. Same thing with these over here. So we say that this square is a parallelogram. Okay. And then we look at the last shape here. Since first thing right away, if you notice that this angle here and this angle here are not equal. So since opposite angles are not equal, we say that this one is not a parallelogram. Okay, so we're done with today's notes.